Okay, so let's get started. We're going to be taking a look at some fundamentals with our PDM module. So understanding our current limitations for high and low current outputs, making sure that the combined continuous current and then the combined inrush or possible inrush current is going to stay below the limitations of the PDM module so that we're not going to run into failsafe shutdown protection in the PDM and then how all of our devices start to shut down because the PDM is overheating or, again, there's just too much current draw going on. Very important to understand those limitations. You can actually test your real-time current draw, whether it's inrush or continuous, using your PDM software when you're controlling the device, doing a test function. I'm going to demonstrate that here, looking at turning on some LED lights, just so you can kind of see what that looks like here on screen and starting to communicate with the PDM module, just a basic test. But you'll be able to use that to actually populate an Excel spreadsheet to go in and then figure out and calculate what the maximum possible continuous amperage draw is going to be on all your devices, as well as the possible inrush amperage that you have on your devices. Now, normal devices such as a light or turning on a pump, let's say, they're going to have not a large inrush amperage spike. It's really going to be things like cooling fans that have a pretty large inrush spike, depending on how you're controlling that device. If you're going to be doing an on-off style control with a cooling fan, well, you're probably going to get a decent inrush spike where your amperage spikes up when the device turns on and the fan turns on for a brief second, and then it settles down into continuous amp draw, which is much lower. You'll find if you're pulse width modulating your fan, then that's going to be a different situation. You'll find that you can do a soft start feature here in the output control and a high current output with the software. That's going to allow you to ramp up the duty cycle output for the fan control, and you don't get that huge inrush spike on a high current output. So we'll get into some of those details in other tutorials, but you just need to understand that inrush and continuous amp draw is something we have to be factoring in and be aware of. So we want to make a wiring plan and being able to account for those amperage limitations or those amperage draws on the devices that we're working with. So let's actually go here from our PDM Link software. I'm going to jump over. I have an Excel spreadsheet that's open right now, and this is something that's found. You can actually open this up and find this in our G5 course training packet. It's going to be called PDM Link Course Calculator. Currently, there's only one page in this course calculator. I think I'm going to be adding a couple more pages in a future training tutorial, just taking some screenshots and putting some notes in the Excel tabs to be able to turn on and set up common things like how to set up a cooling fan, how to set up a fuel pump, how to set up a window regulator with a full bridge type of output control. So we're going to get into some more of those details again as we go through future training tutorials here with our PDM. So don't panic if you're not understanding what some of this language and terminology is going to be. What we're focusing on right now is the page that we have open here. We can find in this spreadsheet, we're going to find the PDM outputs. This is going to be our high current output 1, 2, 3, 4. Then we also have our ADIO or low current outputs 1 through 8. We also have here custom name. So this allows you to go in here and enter in what that device is going to be wired to. So for example here, high current output 1 could be cooling fan. Output 2 could be fuel pump control. Output 3 could be anything. Could be electric power steering. Doesn't really matter. You can go ahead and name the device that you're wiring to for the output. So you have a nice kind of layout chart here of what's going on. And the next thing we have here is our inrush amps. Now the inrush amps is essentially applicable to our high current outputs 1 through 4, although our low current outputs also have an inrush amp that we could technically document. However, we can't see the inrush or continuous amp draw on an ADIO output currently. That may change in future software revisions, but for right now, we can only monitor our inrush and continuous amps here with the high current outputs, but we'll be able to go in and potentially, again, in the future, be able to see what's going on with these ADIO outputs. But what we want to find here is our high current. These are things that could potentially control a cooling fan. We're not going to be controlling a cooling fan with a low current output. It's only going to be our high currents. So the inrush amps here have to be documented. The continuous amps for all of our devices here also should be documented and noted. And then down here below, we see a row called total. What this is going to be doing is totaling up all of the potential inrush amp draw and all of the continuous amp draw here that we have on our PDM module. Right now, these values are green. If I start putting in values here that get up to the upper limits of what the PDM can support, this is going to start to change from green, and then an orange is getting closer to the top maximum range that it can go and actually support in terms of amperage outputs. And then when it turns red, that means that you've exceeded and you're dangerously close or exceeding the actual amperage, continuous amp or inrush amp that the actual PDM module can support. So let's go over a few things right here real quick. Let's talk about some of the details we need to know about our PDM when we're getting started here, setting up all of our devices. We can find here the maximum combined inrush limit for all of our outputs. So this would be if we turn on a device, it has a certain amount of inrush where the amperage could spike. Again, normal things like LED lights aren't going to have a spike in amperage. You're going to find that with really cooling fans, something that's going to be more of a higher torque motor output that could have go ahead and have that spike in amperage. But we'll find here the maximum combination of all of the inrush for all the devices, if they all turned on at once, 160 amps. So we have to.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.